Aluminium serves as the primary material for most aircraft structures due to its strength and lightweight properties. High-strength aluminum alloys are predominantly used for the fuselage and wings of commercial and military aircraft. Aluminium makes up 70 to 80% of the structural weight in airliners and over 50% in military aircraft, though this percentage has decreased with the rise of carbon fiber composites. For safety, aluminium is not used in its as-cast condition for critical structures, adhering to strict toughness and strength requirements. The 2000 series aluminium alloys, featuring copper as the main alloying element, are known for their high strength and fatigue resistance and are widely used in key aircraft components. These properties make the alloys well suited for fuselage skins, lower wing panels, and control surfaces. 624 alloy is a typical Duralumin alloy in the aluminum-copper-magnesium system. The 7000 series alloys, primarily containing zinc, also represent a significant portion of structural materials in aviation. Aluminium alloys undergo processing through plastic forming operations to enhance their strength, resulting in wrought metals. The yield strength of a wrought aluminium alloys is typically 5–200% higher than the cast metal with the same alloy composition. Plastic forming techniques such as forging, extrusion, and rolling significantly improve the mechanical properties of aluminium. Forging involves shaping metal under high compressive forces, vital for creating thick sections of aircraft structures. The 2000 aluminium alloys are forged at 460 degrees Celsius, whereas the 7000 alloys are forged at 4440 degrees Celsius. Extrusion pushes metal through a die to create components like beams and rods, essential for aircraft frames and wings. High-strength aerospace alloys, including 2000 and 7000 aluminium alloys, are referred to as hard alloys because they are difficult to extrude. Rolling is used to transform thick metal into thin sheets for aircraft skin and structural components, ensuring uniform thickness and integrity. The rolling process usually begins with hot rolling of the ingot to close any pores and break down the coarse grain structure of the casting. The thickness of the ingot is reduced progressively by a series of rolling operations. Sheet forming allows for the production of curved panels crucial for large aircraft structures, utilizing pressure to shape rolled metal sheets. The pressure used to stretch the sheet is applied through male or female dies or both. The sheet is pressed into the rubber pad under force applied through the punch. This combination of advanced aluminium alloys and processing techniques underscores the significant role aluminium plays in building safe, effective aircraft. Thank you for watching. Remember to like, comment, and subscribe.